Hello, I'm Wayne Leck and I'm going to be doing question 8 now of June 2013 AQA Core 3. According to the examiner's report, most people accomplish this question quite well, but it was better than in previous years, it says. So in previous years people didn't do so well at this, so I think it's essential that we go through it anyway. So it's question 8, there's an A and B. I'm going to go through A first, then go through B. So let's turn to the whiteboard and do question 8. Alright, so question 8. The graph shows f of x equals natural log of 2x minus 3, where x is greater than 3 over 2. A part 1 is find f to the minus 1 of x, so the inverse function of x. Now, most people know what to do at this stage. You swap your x and your y essentially. So at the minute, we've got like a y equals ln 2x minus 3. Then you swap around the x and the y, so we get x equals ln of 2y minus 3, and then solve for y. So firstly we get rid of the ln, so we have e to the x equals 2y minus 3. So then e to the x plus 3 all over 2 is our y. Okay, so taking the 3 over and divided it all by 2. Another way of writing that is a half e to the x plus 3 over 2. That would also be accepted. You could also just put a half outside the bracket of e to the x plus 3, but I'm going to leave it as e to the x plus 3 over 2. And then what we would do is we would then change that y to be f minus 1 of x, the inverse function of x. So that's what it equals. Most people were fine with that. Some people didn't know how to get rid of the ln. If you exponentiate both sides, it gets rid of the ln on that side, but you have to exponentiate that side as well. And that's how you get rid of the natural log. So part 2, state the range of f to the minus 1. So the range of the inverse. Now you should know that the range of the inverse equals the domain of the original. That's normally true. So f to the minus 1 of x is greater than 3 over 2, because that was in the question, but that was 3 over 2. This whole thing was x was greater than 3 over 2, so that was its domain here, which is what you have to realise, because it doesn't explicitly say has the domain x is greater than 3 over 2. So the range must therefore be the same for the inverse function. Part 3, sketch f to the minus 1 of x, stating coordinates where it crosses the x-axis and stuff. If it does, or if it crosses the y-axis, we don't know yet, it doesn't explicitly say that. So f to the minus 1 is an inverse function. It means it's reflected in the line y equals x, which is going across diagonally like that. So imagine putting a mirror diagonally against that. It's just going to flip it in the y equals x plane, and it's going to look like that. And we can see it crosses here, so we know there's going to be that point there. Well, what is that point there? Well, we're reflecting in the line y equals x, so if that is the line y equals x, our new graph is up here like I've just drawn. So this point here will be that point there in the y, and that point happens when y equals 0, so when that is equal to 0. So we'll have 0 equals ln 2x minus 3. Exponentiate both sides, e to the 0 is 1, so we'll have 1 equals 2x minus 3, plus 3 is 4, divided by 2, and we get this point to be 2. Alternatively, you could assume you got this right, and if we get this right, it will be the same thing. We'll put 0 into here, because this will cross the y-axis when x equals 0, so e to the 0 is 1, plus 3 is 4 over 2 is 2. So you could do it either way. You could go to there, which is what I would advise to do. That's why I did that one first. Is if we go to this graph and put it into that equation, you get the same thing. It's just that equation is definitely right, whereas there's a possibility you worked this out wrong. If you really trust yourself, then you can go ahead and put the value straight into that one. But I would advise you go for the one that's definitely true and just try rearrange it there. And that's 2. And that's part A, and then there's part B. Let's go into part B on the next whiteboard. Okay, so B, it starts off by giving us some new information. G of x, or another function of x, equals e to the 2x minus 4. That's what it gives us. B part 1 says find g f of x in the form ax minus b squared minus c, where a, b and c are integers. So, for your benefit, f of x, I'll remind you, is the natural log of 2x minus 3. Obviously in your actual paper, if you were doing this, that would have been right above it, but I've had to do it on 2 different whiteboards, so I'll remind you. Now, g f of x, that's when we take our f of x, which is this, and we put it into our g of x function in place of any x. So, g f of x equals, so we have e to the power of 2 lots, but now instead of x, we have this natural log of 2x minus 3. And we've still got this minus 4 at the end there. And what we can do with e to the anything, if it's got a coefficient of 2, then that's the same as e to the natural log of 2x minus 3 squared. Okay, so this here is equivalent to this here. I'll separate it with my blue pen so you can see they are different things in case it's getting confusing. That is equivalent to that. Now e to the power of natural log cancels out e in the natural log, so what we're left with is just the 2x minus 3 squared, and then we've still got this minus 4 from here. And it wants it in the form of ax minus b squared minus c, which it is in. Some people made the mistake of expanding it. Either they didn't notice it, or they didn't read it properly, or they forgot that it needed to be in this form, and they expanded this, and that was marked wrong. You lose your final mark. Part 2 then. Find fg of x, and hence solve fg of x equals ln 5. So fg of x is the opposite way round. We take our g of x, which is this, we put it into our f of x in place of any x. So f g of x equals the natural log of 2 lots of, instead of x we put in our g of x, e to the 2x minus 4, and then we've still got this minus 3 after that. So that's what we get, and that's sort of a general expression. You could expand that and keep that as a general expression. But let's go on and go straight to solving it. So we get the natural log of, and we can expand what's in the brackets now, 2e to the 2x. Okay, so you've got the 2 times the e to the 2x. Then you've got 2 times minus 4, which is minus 8. I'll write all of this in this step. Minus 3. Now minus 8 and minus 3 is quite easy. You could have done that in one step to simplify that, but I'll just put it anyway so you could see what I was doing. And that equals the natural log of 5. It's told us here to solve it for x. That's what we've got to do. Now, if we were to exponentiate both sides, that would get rid of the natural log on both sides, and that's a good start. So we've got this 2e to the 2x. Now I am going to simplify it. Minus 8 minus 3 is minus 11, and that equals 5 because we've got rid of the natural log on both sides. So that means 2e to the 2x equals 16. So e to the 2x equals 8 because we're dividing both sides by 2. 2x, I'm running out of room here, put it up here. If we take the natural log of both sides, we get 2x equals the natural log of 8. So our final answer, I'm running out of room, but our final answer, if we rub off this bottom line, is x equals a half natural log 8, or natural log 8 over 2. That's what x equals. So in terms of marks, here was worth 3 marks, here was also worth 3 marks. I didn't speak about the marks on part A. Part A, part 1 was worth 3 marks, part 2 was worth 1, and part 3 was worth 2. So altogether question A was worth 6 marks and question B was worth 6 marks. So question 8 is 12 marks altogether. Quite simple stuff, but easy arithmetic mistakes. You might have expanded this wrong. You might have, instead of putting f of x into g, you might have done g into f there, and the opposite here. Make sure it's the inner circle put into the next one. And if there was one in front of this, like h, f, g of x, if h of x was something else, then you put g of x into f, and then that into the next one, and so on and so on. But I don't think that's going to come up as a question. And so hopefully this helped at least a little bit. This has been question 8, and I'll see you at question 9.